Hello, parents and any teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, we're going to be looking at some addition strategies, which are algebraic properties, and the meaning addition that your child may experience in grade 5. Now, notice how I have some different manipulative materials available, and you may see your child using these or pictures of these in grade 5. Now, we use base 10 materials. We actually begin using these typically in grade 2 to start to build the idea that when you add like places, you combine like terms. So we combine hundreds with hundreds, tens with tens, ones with ones. In grade 5, they extend that up into decimal numbers, and they need the understanding that you combine tenths with tenths, hundredths with hundredths, thousands with thousands. And so this is a model that allows us to build that understanding. Now notice I have paper versions also. And in the paper version, when I'm wanting your child to be able to draw a picture of the 100, I don't want them drawing in all these lines, just the outline. And for some of your children, it's helpful for them to see the outline of that piece instead of seeing all the squares drawn in. Now, another material that you may see is a fraction kit. And typically, children make this fraction kit in grades 3, 4, 5, because it is important that your child can construct fractional units. And they might fold it into 2 equal pieces, 4, 8, 3, 6, and we use those pieces to model the problems that they're doing. Now, notice how none of my fraction pieces are labeled, and that's purposeful. And I hope that you'll see that we're not using materials just to use them. We're using them in very purposeful ways to build understanding, because we know through those 5 strands of math proficiency, part of it is conceptual understanding. That builds to procedural fluency. And notice the models we're using. Now, I'm not labeling these. That's purposeful, because if I label these, it becomes a reading task. If I were to label each of these as 1/3, I just need to read the piece and know that it's called 1/3. But see, how do we name a fraction amount? We know that 3 of these pieces, same size pieces, make the whole, so one of them must be called 1/3. If I label the pieces, I lose the embedded practice, right? It's just, as I said, reading. I just need to name the piece. So you'll find that I quite often use construction piece, the construction pieces, paper pieces, for my fraction kit versus commercial pieces, because the commercial pieces tend to be labeled. Now, another thing that we're doing as we move into the fraction decimal relationship, we start to look at denominators of 10 and denominators of 100, because that builds that link. And you may find if I were to write the common fraction version of 100th, it would look like this. Whereas the decimal fraction version may look like this. Now notice how I'm calling this a common fraction and this a decimal fraction. They're both still fractions. But when I have denominators that are powers of 10, 10, 100, 1,000, 10,000, see, I use that now comes into our place value system. Now you may see me write 100th using a decimal point without a leading 0 and with a leading 0. See, the leading 0 is not required. It can be helpful to help me know that the same as 100th. But what we're trying to do is make a strong connection between that common fraction version and the decimal fraction version. And even the way I read it, 100th, I read it the same way no matter the symbol that I use. Now, because we are making that connection between common fraction, decimal fraction, and we have this model, I mentioned this as a whole number model, but see, eventually we can have your children thinking of this as our whole. What would this part of it be called? See, I get tenths. What would this part of it be called? Hundredths. You might see models that look more like this coming into play. We might have a 10 by 10, where each of those pieces are hundredths. Or I might have something that looks like this, where each of the pieces are tenths. And again, we're trying to build the connection and use these strong images so that when your child in grade 5 is starting to add decimals, add these mixed numbers, add fractions, they have strong imagery. And part of what's foundational for what we'll be doing in grade 5 is building connections between tenths and hundredths, and then extending that up into thousands. Now, think about, I could color in 3/10. And the one thing that children need to understand is that I don't have to color in consecutive bars to be 3/10. I can color in any three of these, and I've shaded in 3/10 of the area. And we have your child picture sliding this on top of this. Now, what do we have? If I color in those same columns, those same sections, see, I've colored in the same area of each hole, but in one case, I'm representing that area using tenths, the one on the left, and in the other case, I'm representing that area using hundredths, the one on the right. And so we help your children make that connection between 3/10, common fraction, I could call this, and 30 hundredths, common fraction version, or 3/10 and 30 hundredths. When I was in school, I remember learning a rule that just said, well, you can just add zeros. It didn't change anything. It does change something. It changes the size of the pieces that we're talking about, those fractional units. Now, do you also notice that I'm not calling this 0.3 or 0.30 when I'm getting to decimal numbers? I'm still calling it 3/10. 30 hundredths. And that's important that your children read this using those place value names. Now, there will be times when we have a decimal point where we'll say 0.3 or 0.327 when we're wanting them to write it or perhaps enter it into a calculator. But for the most part, if this is the decimal number I'm working on, I would read it 327 thousandths. The same time we're building the foundation, because it's about combining like units, that this is tenths, this is hundredths, this size pieces, and then the thousandth size piece, I could cut each of these into 10 equal sections. Okay, so building that foundation, we're picking the models purposefully and building connections between common and decimal fractions. Now, just to look at a couple of these, and if you're interested in the whole number version of combining like size units and working with this and using associative property, which is one of the properties we'll look at, please check out the 3rd grade video or the grade 4 video. I'm going to show you those same ideas, but we're going to do it a little differently. Okay, now 3rd grade, let's say I'm doing whole number addition. One key strategy that we'll have your students use is combine like terms. Now, in grade 2 and grade 3, they will draw pictures. Think of this. But for my hundreds, I'm going to draw a picture that looks like this. When I have the kids draw a picture for 10, it tends to look like that. And a picture for 1, we use dots. When we get up to 1,000, I tend to have them draw a picture of a regular hexagon. If only I could draw one for you nicely. And then we find the center point and connect opposite vertices, every other vertice. So we have these pictures, and the reason we're asking your child to draw the pictures isn't that we think they can't just add the columns if they were to learn that algorithm. It's because we want it clear to them that when you have 352 and you're combining it with 427, you have to combine hundreds with hundreds, tens with tens, and ones with ones. Now, I know when I was in school, we would have taken this and we would have written it vertically. We would have focused on alignment. All the places had to line up. And we would have talked about this as 2 and 7, 5 and 2, 3 and 4. But you'll hear that we want your child to use place value. That algorithm works, but it doesn't build the algebraic foundation for combining like terms, like size units. That's important here, but it's also important when they're getting into decimal addition and fraction addition, mixed number addition. Now, if you look at what I've done here, you may hear the term partial sums. And what happens with partial sums is we're combining hundreds with hundreds, tens with tens, ones with ones, and we're essentially writing the sum of the places when we combine it. Now, I can write it this way. Notice how I went left to right. I could have gone right to left. I could have had 970 and 700. I could have started in the middle. See, when I'm using place value and combining like size units, I could have written this problem like this, and the student should still know you combine hundreds with hundreds, tens with tens, ones with ones. Now, I could change this. See, the concept doesn't change. Combine wholes with wholes, tenths with tenths, hundreds with hundreds. If I'm doing this problem using partial sums, I'm going to write it horizontally. I know I need to combine wholes with wholes. 3 and 4 is 7. Tenths with tenths. 5 tenths and 2 tenths is 7 tenths. Hundreds and hundreds. 2 hundredths and 7 hundredths is 9 hundredths. It's similar. I'm still thinking of combining like terms. That's a place value for whole numbers, but that takes us down into decimals. And what I'm picturing with those combining wholes, right, or those units, this is my model for hundredths and tenths. But notice my whole is the same size. I can't compare hundredths to tenths if I have two different size wholes. Well, I can, but it's not going to give that same comparison that when I have the same size whole. So we're building that imagery. We're thinking about combining like terms. That's an algebraic idea. Now, let's use the same idea for mixed number addition. Let's say I'm going to do 1 and 2, 6 plus 3 and 1/2. Okay. Now, we do this. I'm going to draw the picture. I'm not going to use the actual pieces. Okay, we're not going to use the fraction kit pieces, but let's just say I've got 1, and I'll apologize right now for my drawings. I hope you can see what I'm doing though. I have 1 and 2, 6, and I want to combine that with 3 and 1/2. Now, I could have drawn this picture with these representations side by side. I could have drawn this with the holes on top as I drew this one. But you see, when I'm doing this picture, I tend to draw it this way because I want to see how the pieces fit together. But in this case, I have to combine wholes with wholes, ones with ones. So 1 whole and 3 wholes is going to give me 4 wholes. But what do I have to do? I have to combine like-sized pieces. Right now, I have something in terms of 6 versus a half. That's why we found common denominators, like-sized pieces. Least common multiple gave us that like-sized piece that we needed, okay? So when I'm doing this, if I've done enough work with fractions, and they've done enough of drawing and looking at the relationships, see, I can see that 3 1/6 pieces is going to be the same as the half. I can use that idea. So when I'm combining, I have to think of an equivalent form for that 1/2. And I combine the 2 1/6 pieces with the 3 1/6 pieces, I end up with 5 1/6 pieces. Here, these are partial sums for mixed numbers, okay? So I've got 4 and 5 6. All right. Now, let's say I'm doing 2 and 25 hundredths, and we're putting it together with 1 and 75 hundredths. See, with US currency, there should be bells going off right now. I have a quarter and I have 3/4, 75 cents, right? I can think of this in many ways. And we know for a student to be mathematically proficient, that's part of the equation, right? It's having conceptual understanding. It's having procedural fluency, which means I can flexibly use a variety of strategies that are all efficient. And I can take something that when I was in school would have been a paper and pencil task, as I said earlier, into something that's mental arithmetic. See, I can equate this in my mind and think about adding this together. I have 2 wholes combined with 1 whole. If I want to do it as partial sums, there's part of it. I have a 1/4 piece put together with 3 1/4 pieces. That's going to give me 4 1/4 pieces, or a whole. So I end up with 4 here. I could have thought of this as combining like-size units, right? I can think about combining wholes with wholes, tenths with tenths. And then when I get hundredths with hundredths, it's understanding that equivalency that I can think of 9 tenths as 90 hundredths, or I can think of 10 hundredths as 1/10. In any case, I still end up with 4. Or I can think about just that the hundredths is hundredths. 25 hundredths put together with 75 hundredths is 100 hundredths. So I could also think of this. Let's say I was thinking in terms of common fractions. I've got the wholes with the wholes. I've got the hundredths with the hundredths. There are my partial sums. And what do I know about 100 hundredths? Or I could have stuck with it like this. I would have ended up (100 hundredths). Flexibility is the key. Playfulness with quantity is the key. Having the imagery that goes along with what we're doing and building the idea of combining like terms. We start with that with our place value models like this in grade 2. We extend it up into hundredths in grade 3, and we continue using that in grade 4. And then we go over and start to do this with mixed numbers. So partial sums is just showing the ways that we're combining the places. It's the sum of the places, which frees us up from having to do alignment, from thinking about alignment. It also supports the understanding of place value. So I'm not teaching separate lessons to your child on place value. I'm reinforcing it through their computation. So that's one side of it. Another side that another strategy, I guess I should say, that we're teaching and working with your child on is the associative property. So I want to look at this problem. We have this bridge to 10 that they learn in grade 1 and grade 2 and use in grade 3. We have a bridge to a whole that we start to develop in grade 4. And just to think about this one, let's see this picture again. Here's 2.5. Sorry. And let's do 3 and 5/6. Well, notice how I'm making a similar picture to what I did with my mixed numbers when I was showing that with combining like terms. The idea of combining like terms is not omitted here. I combine wholes with wholes. I can combine 6 with 6. I can't combine a 6 with the half. But do you notice how these 3 pieces, the way this is drawn, these 3 pieces could slide right up in there and make another whole. So I could rethink this. I could slide these up. Or if I think of 1/2, because I've done all that work with those relationships, as 3 1/6 pieces, do you see how this one could slide right down there? Now, essentially what I'm doing, and the picture, the image helps me. And this is why we're wanting to use the imagery, because it will link to the property. Even if your child knows the rules and the algorithm for adding this imagery will build that property of the associative property. Now, I'm going to rewrite this using that equivalent idea of 3 1/6 pieces here, 3 6. I'm putting that together with 3 and 5/6. Now, do you notice how I keep using terms like putting together and join and combine, even though I know we name that plus? The challenge is, though, your student doesn't see, your child doesn't see the word plus in a word problem. They see things about combining and putting together and joining, the meaning of addition. So whenever I'm using symbols, I tend to still use words like combine and join and put together. So I'm building the language of word problems when they're seeing these symbolic representations. Now, those aren't my meanings for addition. Those I learned years ago from Cognitively Guided Instruction Project out of the University of Wisconsin, other research that's been done, thinking of action of word problems. We're using that even when we're computing mixed numbers, okay? Now, think about if I'm sliding this right down in here, what I'm doing is I'm thinking of 2 and 3 6 as 2 and 2 6, put together with 1 6, right? I'm kind of separating this one out. And I'm going to join that with the 3 and 5/6. But when I slide this down, instead of associating 1 6 with 2 and 2 6, I'm going to associate the 1 6 with the 3 and 5/6. See, it's the representation of the associative property. I'm purposeful in my models that helps me see the associative property. Something that would have required regrouping when I learned to add this type of mixed number problem and getting least common multiples and common denominators and equivalent fractions, I can picture sliding it in, but it's the imagery of the associative property when computing with mixed numbers. Now, when I have this, I have 2 and 2 6 put together with 4. I can do this in my head, right? I don't need paper and pencil. We're making it a mental arithmetic problem. Now, once I have the 6 and 2 6, in some cases, we want them to write this in a simpler form. Often I ask your children, well, how could I make this using fewer pieces? We're building that connection. I can make this also using 6 1/3. In some cases, there's not a requirement to go in simplest form because this is correct also. So you're going to see some variations perhaps from what you were asked to do, right? But think about this associative property. So the associative property will work for problems, whole number problems, and your child begins to use this actually in grade 1. They're introduced to it with just single digit numbers, and then it builds up until they're getting into grade 3, doing it with multi-digit, grade 4, 2, 3, 4. But see, think about how I can think of 287. I can make this the same as 284 plus 400. How do I do that? See, I've now converted something that I would have needed to use paper and pencil for into a problem that I can do mentally. I know that's 684. It's not challenging, right? Where this one would have required me when I was an elementary student to write it vertically. I would have focused on the columns and it would have looked something like this. Okay, so I would have seen something where I had to do regrouping. This works, but it's requiring paper and pencil for a problem that doesn't need paper and pencil. Because how am I thinking of that 287? Well, I can think of it as 284 plus 3. And instead of associating the 3 with the 284, I'm going to associate the 3 with the 397. It's not a trick that we're doing. It's using the associative property. It's an algebraic property that allows this to work. So if I can do this with whole numbers, that associative property, I could have written it this way. It's essentially the same problem, right? 2 87/100 plus 3 97/100. Well, I can think of 2 87/100 as 2 84/100 put together with 300. Instead of associating the 300 with the 2 84/100, I associate the 300 with the 3 97/100. Again, this becomes a mental arithmetic problem. I have 2 84/100 put together with 4. 6 84/100. It's why we're using more algebraic approaches to computation. It's why we're having your student do things with physical materials, drawing pictures of things, because it is the imagery of the algebraic properties. And we're wanting to use those as much as possible. Now, I want to show you one more strategy that your children are asked to do, and that's a doubling strategy. Now, I'm going to start with this problem. Double 3 1/3. Okay. Now, if I double 3 1/3, see, think about that picture again. If I want to represent 3 1/3, here are my 3 holes and that 1/3 piece, right? And I'm doubling it. Now notice this time I chose to write it, draw them side by side. Doesn't matter. I'm just trying to show 2 groups of 3 1/3. But now how did I make that? To show a double 3 1/3, well, I show double 3 put together with double 1/3. See, how did I think of 3 1/3? Well, 3 1/3 is the same as 3 plus 1/3. Double 3, double 1/3. This imagery makes it very clear how I can do the multiplication, and this works because it's the distributive property. When I learned about this, I would have had to change this to an improper fraction, it was called, right? A fraction that has a numerator larger than the denominator. I would have converted this to an equivalent form, we might say. So I would have been doubling 10/3. And then once I doubled that and got 20/3, I would have turned back around to get to the point where I know I'm combining 6 plus the 2 1/3 pieces, or I get 6 2/3. The distributive property saves me some steps and will always work too, because it's the distributive property. Now, using those pictures, using the images, same idea here. Let's say I want to do a double. Let's do. Now this 2500ths again, it's familiar. But how can I think of it? Well, because it's 2500ths, it's one of those key numbers, benchmark numbers, one of those nice ones. 25% links to a quarter in terms of currency, quarter in terms of fourth of a dollar. So we have lots of different images for this. But how do I find double 3 and 2500ths? Well, I can think of it as double 3 put together with double 2500ths. Notice parentheses here are not required. Order of operations, I do multiplication, left to right, then addition. So in grade 5, they will be looking at order of operations, but we start to look at this type of notation much earlier, right? Without focusing in on order of operations, but just notice my language. Double 3 put together with double 2500ths. Well, what do I have? I have 6 put together with 50/100ths. Now, think back to this. I can write this answer 2 different ways. I can either say this is 6 and 50/100ths, and notice my use of the word and for the decimal point. Or I could write this as 6 and 5/10ths. Those would be equivalent. I could also have done this by thinking about the 3 and 2500ths in terms of the places. See, I could have thought of this as 3 plus 2/10ths plus 500ths. So I would have doubled the 3, double the 2/10ths, double the 500ths. Gotten that same answer, okay? So I'm thinking of doubling the pieces. I can do that mentally, especially when I was thinking about this back in this form. That was very easy to do mentally. Let's look at one more. Double 23 and 41/100ths. Now, can you do this one in your head? Double 23 is 46. Double 41/100ths, 82/100ths. Done. I can think of it all in terms of hundreds. I can think of double 20 as 40, double 3 as 6, double 8/10ths. I'm sorry. I'm getting the answer ahead of saying the problem, right? Double 20 is 40. Double 3 is 6. Double 4/10ths is 8/10ths. Double 100th is 200. In any case, that is using the distributive property. Again, we're using specific models, specific materials to help build the imagery of these algebraic properties, to turn something that we learned using an algorithm which works. And your child will also learn that. We aren't avoiding that. But instead of learning purely arithmetic approaches to computation, because I would have learned something that looked like this, right? We're using the algebraic approaches. Algebraic ways of thinking about using place value, getting ready for combining like terms. We're using associative property when we're combining, right? When we're adding as a way to turn a paper and pencil task into a mental arithmetic task. And we're using it to think about multiplication and getting into the distributive property. And we can do this quite early with the addition strategies and then revisit it when they're getting into multiplication. If you found this video helpful, I hope you will give it a thumbs up. Please click on the bell for notifications and subscribe to the channel so that you know when other videos become available. If you have children in other grade levels, I hope you'll check out those grade level specific videos. And thank you so much for watching.